Hello and welcome to this video on boundary estimates in latent class analysis. My name is Geiser. I'm an instructor with QuantFish. In this video, I want to discuss an issue that frequently occurs in latent class analysis, and that is the occurrence of so-called boundary parameter estimates. Specifically in this video, I will address three different questions. The first one is, what are boundary parameter estimates? How can you detect them? And then second, I want to talk about whether those boundary parameter estimates are problematic and why. And then finally, I will address the question of what you can do about them. So let's get started, and let's first of all talk about what boundary parameter estimates are in latent class analysis. And that's really easy to understand. So in latent class analysis, we estimate probabilities, class probabilities, and then also so-called conditional response probabilities for our items or latent class indicators. And so when you obtain a probability of exactly 0 or exactly 1 for a parameter in latent class analysis, then that is called a boundary parameter estimate, because this is a value that is exactly at the limit, or those are values that are at the limits of what probabilities can be. Probabilities cannot be smaller than 0 and they cannot be greater than 1, and so therefore values of 0 and 1 are exactly at the boundary of the admissible parameter space for probabilities. Now these do occur frequently for conditional response probabilities in latent class analysis, meaning for the item probabilities that we use to interpret the latent classes. So for example, this could then indicate that in a given class nobody endorsed a given item if the probability were 0, or 100% of people in a given latent class said yes to a given item or solved a given item. And so you can already see that there's a certain issue with that potentially, because those are extreme values, and we'll talk about that more in a little bit. Now, how can you detect, or how can you figure out whether you have boundary parameter estimates in your model or your estimation? Most latent class analysis programs will issue some sort of warning message about that. For example, here's one that the program Mplus issues, which is an excellent program for latent class analysis and other mixture models. So Mplus will say, in the optimization, one or more logit thresholds approached extreme values of -15 and +15 and were fixed to stabilize model estimation. These values imply probabilities of 0 and 1. In the model results section, these parameters have 0 standard errors and 999 in the z-score and p-value columns. So Mplus uses a logit parameterization of latent class analysis, and therefore extreme probabilities of 0 and 1 correspond to logit threshold values of -15 and +15 in Mplus, which explains this message here. And so then when you go to your model results section, to the parameter estimates, in this case I went to the results in probability scale, you will locate those extreme probabilities. For example, here for an item X, where the first category has an estimate of 0, the second category has an estimate of 1 accordingly. And then you can see the standard error SE here, it has zeros in its column, and the z-score estimate divided by standard error also has zeros. And then the p-values actually should have 999s. In this case, they don't for whatever reason, so they have p-values of 1.0, which doesn't make any sense when you have no standard error. So this is how you would find them. You would probably get some sort of warning message about them, and then subsequently in your parameter output, you would either find extremely large logit threshold values or extremely small logit threshold values, or you'll find probabilities of 0 and 1. So that's what they are, and that's how you can find them. Now let's talk about whether boundary estimates are problematic. And so first of all, they are problematic in the sense that they are implausible. So a boundary value of 0 means that for a given item, nobody in that latent class endorsed that item or solved that item. And so that is kind of, in many cases, it's kind of an implausible scenario, so that there's a clear-cut 0-1 probability for a given item in a given class. Under certain circumstances, this may be plausible. For example, when you have a speeded test and you have a latent class of individuals who run out of time on that speed test, for example, a cognitive abilities test, then it may be plausible that 0% in that latent class solved the last items of the scale. So they're not per se always implausible, but oftentimes we would say, well, this seems unlikely that everybody in this class scored 1 or scored 0. So this is something that therefore is per se somewhat problematic because of the fact that it's implausible, that it was implied too that this item is perfectly reliable, has no measurement error in this given class, and that's something that we typically don't assume. Now, more importantly though, boundary parameter estimates are often a symptom or sign of other more severe problems. So they're not just implausible, but also they can show severe problems with your analysis and or with your latent class model, such as the fact that the model may be under-identified. So this could be a symptom showing that your model is not well defined for the data, or that it is structurally under-identified potentially. It could also be a sign of local likelihood maxima. Usually we use maximum likelihood estimation with latent class analysis, and latent class models are known to often produce local likelihood maxima where you don't find the optimal solution with a single set of starting values or even with multiple sets of starting values. And so therefore this could be a sign that you ran into a local maxima that represents an invalid solution. Also, it could be a sign of overfitting or model misspecification in some other way, meaning, for example, having extracted too many latent classes where some of those classes are not needed, and then boundary estimates occur more frequently when you have additional spurious extra classes that you don't really need. It could also be a sign of an insufficient sample size. That's when they frequently occur as well. When you have a small sample, maybe too small a sample size for your analysis to be valid or to produce reliable results, then also we see boundary estimates more frequently. Now, another thing is that we already saw is that boundary estimates come with no standard errors and test statistics. So if you're interested in standard errors, you won't get them for a boundary parameter estimate, and you will also not get a test of statistical significance, which oftentimes we don't care about that so much for conditional response probabilities. However, the standard errors may be important for you to know about and look at, so that you can also evaluate the quality of estimation or the uncertainty in the estimation. So having no standard error is something that we also don't typically really like. Now let's talk about what we can do about those boundary parameter estimates. First of all, and that is relatively simple, is we should always make sure that we collect sufficiently large samples for a latent class analysis. And that means typically several hundred cases. As a very, very rough rule of thumb, we would typically say that you shouldn't do a latent class analysis with fewer than 300 cases. Although this is a very rough rule and it may not apply to all circumstances, but typically we want to have 300 plus cases for a latent class analysis. If you are unsure about this, it's a good idea to simulate a latent class model to the best extent possible using Monte Carlo simulation methods, so that you can figure out whether a targeted sample size would produce reliable results, including few boundary estimates, no parameter bias, no standard error bias, and so on. Second, we should always make sure that our model is identified. And that is tricky for latent class models because they can come with empirical under-identification, meaning in a specific scenario, maybe a generally identified model may not be identified for the specific set of data. But keep in mind that when you find boundary parameter estimates, this could be a sign of model under-identification. Third, make sure you avoid local maxima. And I have separate videos on this channel where I talk about local likelihood maxima in latent class analysis and mixture modeling in more detail that you can check out. Generally, we can avoid local maxima by using a large number of random sets of starting values for estimation in latent class analysis, and most latent class analysis software programs automate this process. So for example, in Mplus, you can very easily use the starts subcommand in the analysis command to increase the number of starts. Also, you can increase the number of initial stage iterations, which can help avoid local maxima. And so this is something that is very important to check, that your best log likelihood value can be replicated with multiple sets of starting values so that you can be sure that you're not running into a local maximum solution. Also, you should avoid models with too many latent classes if at all possible. So you don't want to extract 12 latent classes typically, or even something that goes above 6-7 classes can be more unstable and can produce boundary estimates more often. Also is more prone to local likelihood maxima when you have more latent classes. So if possible, keep your number of classes small so that you can avoid this problem, hopefully. And then finally, there's also a technical way in which you can prevent boundary parameter estimates, and that is by use of Bayesian estimation techniques that are, for example, implemented in the LATENT Gold statistical software program for latent class analysis, where a Bayesian approach prevents those from occurring. Now, the question is, do you then just make a symptom go away, a symptom of a larger problem when you use those approaches? But in certain situations that can be reasonable, and that is when those boundary estimates are expected or plausible, meaning when very small or very large probabilities for an item are to be expected or are plausible in a given class, then those Bayesian methods may be a good choice. I hope you found this video useful to learn about boundary parameter estimates in latent class analysis. Also check out the description for additional resources, including courses on latent class analysis and mixture modeling that we offer through QuantFish, and I'll see you next time.